Here we're going to have a look at our stainless steel pneumatic actuators. We do these in a double acting and spring return. They're a rack and pinion style, much like the same as our aluminium ones, and probably the majority of the ones out there, although there are other styles. Typical things you'd look for on an actuator: they've got a Nomura interface on the top to mount a limit switch box, visual indicator. They've got a Nomura interface here to direct mount a Nomura solenoid valve. They've got adjustable stops for end position, and underneath they have a ISO mounting interface. So this will obviously vary, as well as the drive size, according to the size of the actuator. But when you're sizing that with your valve, it's important to note what the mounting interface will be for a direct mount, and what the drive size will be in here. This is a star drive. It's sometimes worth actually going up a size in actuator to achieve a direct mount. It's rather than doing a bracket and drive dog, which can be more complex, more time consuming, and more costly. It's sometimes worth going to a bigger actuator if that fits directly. These are a cast 304 stainless steel with stainless steel fixings. So applications we would usually see these in would be underground mining, anywhere where there's a corrosive environment, applications like that. Usually you wouldn't just use a stainless steel actuator if you didn't need it, and where an aluminium one could do. Quite often they're paired with, for instance, a stainless steel Nomura solenoid valve, stainless steel switch box if you need an all stainless steel package. Stainless steel ball valve is pretty standard, whether it's aluminium or stainless steel actuator. Stainless steel butterfly valve as well. Now what we might do is go ahead and show one of these working. We've got this one mounted here on a ball valve. It's direct mount. We've got a stainless steel Nomura solenoid valve and some speed controllers in there just to slow it down a little bit. So what I'll do is just press the manual override. Just get a screwdriver here, and you can have a look at this operating. You can see the visual indicator turn. So what happened, we've got two pistons here on a rack and pinion. The center spline is actually married through the female slot that the male drive goes in. So say the female drive underneath the actuator that the male drive from the ball valve will go into. So there's a mechanical linkage there. As the actuator turns, it will turn the ball valve inside it. And this visual indicator will show you where the actuator and in turn the ball valve is through its cycle. If I just turn that back, you can see it operate. So double acting and spring return look the same. It's the same actuator housing, same in all appearances. The only thing is, in a spring return, they will have spring packs in either end pushing on the piston. What this does is, if you lose air, you get the actuator by itself will return to a resting position. Now this could be fail closed or fail open depending on what you've got it. A double acting, it won't do that. It will, if you take air, it will stay wherever it goes. So they look the same, and for all intents and purposes, you know, the same video will show you how both work. It just depends what you need for your application. If you need fail safe, you would want to go with spring return. So this would typically be a double acting. And what we might do, this is actually a spring return actuator. If we leave this in the open position, as you can see there, and we turn the air off, see, we took the air, we actually vented the air out from this line. It returned to its closed position under spring tension only. If that was double acting, it wouldn't do that. It would just have no air in the cylinder and it would stay wherever it is.